Hello, good day everyone. This is Tevs, welcome back to this channel. We have a Devant 46-inch LED TV, model 46MEL150, that is not powering on but shows only blue standby light indicator. I'll show you how to fix it. If you are interested in electronics and want to learn how to repair TVs and other electronic gadgets, you've came to the right channel. So be sure to like, subscribe, and ring the notification bell so you never miss a video like this. So let's get started. The TV is not turning on. So let's measure the voltages. Even it shows a blue light indicator. Not powering on is mostly caused by a missing voltage or abnormal voltage reading. We will begin measuring the voltage at the main power supply board. We have 5 volts reading on the cathode of this diode. Seems this is the standby power supply. (24.8 volts on this diode. And also 24.8 on this diode. 12.06 onto this diode. Seems the main power supply is turned on. If a power supply has a separate standby power supply, we know that the standby supply is only the one that is turned on. The main power supply only turns on if the TV is turned on by pressing the remote power button or the power button at the TV. The main power supply is only turned on by the motherboard. So let's go to the motherboard and measure also its voltages. (12 volts onto this capacitor. We only measure 12 volts. We should measure other voltages like 3.3 volts, 5 volts, and the V-core voltage of about 1.8 volts, but they are not present. Let's trace where the input of these linear voltage regulators is coming from. The multimeter config to continuity mode. Beep indicates that it is connected or shorted to the pathway. One of the linear voltage regulators part number is 1117-33, it is a 3.3 volts linear voltage regulator. All the inputs of these linear voltage regulators are connected. It seems that this DC to DC converter is where all the linear voltage regulator is connected. It is also connected onto these regulators. Let's measure the voltage of this DC to DC converter if there is an input supply. It has an input voltage of 12.0 volts. This DC to DC converter regulator is the main source of all linear voltage regulators and some DC to DC converters. Maybe the IC of the DC to DC buck converter is defective. Repairing the DC to DC buck converter is not easy. So let's use a ready-made DC to DC buck converter. This buck converter is about 30 volts input and 2.5 to 28 volts output at 2.5 amperes. Let's solder wire on the output and input of the buck converter. Only 3 wires will be soldered, the positive in, negative in, and the positive out. We don't know what the voltage output of this buck converter is. We will know the voltage by looking at the data sheet of the 1117-33. The maximum input is 7 volts. 7 volts is not used in any motherboard or other circuitry and electronic device. Only 5, 3.3, 2.5, and 1.8. So the output voltage of the defective DC to DC buck converter is 5 volts, not 7 volts. Let's test the output of the defective DC to DC buck converter to see if it has good resistance or a short circuit. The resistance is 4.2 kiloohms, and the resistance is okay. Now let's solder the DC to DC buck converter. The positive input will be soldered to the positive of this capacitor, and negative to the negative of the capacitor. Before we solder the output, let's adjust first the DC to DC buck converter to 5 volts. The DC to DC converter is now adjusted to 5 volts. Now let's solder to the missing 5 volt rail line. Now let's try it. The voltage remains constant at 5 volts. The other voltage regulator has a voltage now. The blue light indicator now flashes. Let's see if will gonna turns on. It's turning on now, but it seems the display is not normal. The DC to DC converter is not generating heat. It means that it can handle all the voltage regulators that are connected to it. The ampere output is only 1.3 amperes. I used double-sided tape to secure the DC to DC converter. The motherboard is now okay, but another problem has came out. It's a panel problem. Let's try disconnecting one of the flat wires to see if we can improve the image. Disconnect the flat wire one at a time. The image is not improving. Let's reconnect the wire and disconnect the other one. If one of the wires is removed and the image gets better, it can improve the image, but seems the image is not improving even when the wires have been removed one at a time.
"20 minutes later."
No matter what techniques I try, I can't get the image to come out right. We successfully repaired the motherboard, but unfortunately, we were unable to repair the LCD panel. Even though we have not been successful with the panel, at least you have gained valuable knowledge and found enjoyment in watching this video. Thanks for watching. Don't forget to like, share, and subscribe. Once again, this is Teps. See you again next time. Bye for now.